have one last example here. Hope you recognize this problem from your Chapter 3 test. Part A is a Chapter 3 question, so it's a function whose derivative we have to take and whose second derivative we then have to take. It requires the use of the chain rule. And then we're going to use our answers for Part A to answer a question about critical values in Part B. So we're going to think of radical x as x to the 1/2 power. And just remember that number k, we've been told it's a positive constant. It's just like some number that's multiplying the square root of x. So my f prime of x is 1/2 k times x to the negative 1/2 minus 1 over x, because the derivative of natural log of x is 1 over x. And also the second derivative of x then, that negative 1/2 exponent comes down and multiplies the 1/2 that's already there. I get negative 1/4 k x to the negative 3/2 plus 1 over x squared. Now I've been asked for what value of the constant k does f have a critical point at x equals 1. So what's going on here? A function has a critical point when its derivative, f prime of x, equals 0, or its derivative is undefined, or f prime of x is undefined. And we don't know in this case, we don't know going in which it's going to be, if we're going to find our critical point by setting f prime of x equal to 0, or if we're going to find it by setting f prime of x to not exist. And just notice they've already told us that we're going to look only when x is positive 1. So we're going to end up with an equation. We're going to plug in 1 for x. The thing we're solving for in this case is k, for what value of k. So probably you got a point on the AP test just for setting f prime of x equal to 0. You could have also said f prime of 1 equals 0, because they've told us in this case that we're going to be able to let x equals 1. So I'm going to clear out the screen and I'm going to solve the equation f prime of 1 equals 0 for the variable k. So here we go. There we go. So I know I need to let this first derivative equal 0 when x equals 1. So I'm going to have 1/2 times k times 1 to the negative 1/2. Oops, I copied this wrong. Let's fix this. This is supposed to be minus 1 over x. There we go. Minus 1 over, and I know I could plug in 1 for x. So what do I have? I have 0 equals 1/2 times k. 1 to the negative 1/2. That just means 1 over the square root of 1, which is just 1. Simplifies to k over 2 minus 1 over 1 is just 1. So I know 1 is k over 2. I can multiply both sides of this equation by 2, and I get 2 equals k. So the function f has a critical point at x equals 1 if k equals 2.